So, hi everyone, this is the cloudonaut podcast pre-show. We are still getting ramped up for the show. So, Michael, how is your day going so far? What have you been up to?
I think it's going quite nicely. So I kind of closed a couple of loose ends. So I merged a couple of pull requests and things like that.
Perfect.
I finished a couple of tasks that were open from yesterday. So I'm quite happy with that. I closed a couple of fix me's in the code.
Wow.
So that's always good.
You've-
So it's kind of clean up
You've-
activities all day long
Cool.
so far. So yeah.
So I've written a blog post that I have procrastinating for I think 3 months now. So Matt, if you hear this, your blog post is coming out soon. So that's my main achievement for today. Okay, so I think we are all set. So camera, audio, everything seems to working fine. So let's then start. Let me try to find the intro. Here we go. Welcome to the cloudonaut podcast. We are your hosts, Andreas and
Michael Wittig, and this podcast is about building on AWS. You can follow our journey of bootstrapping Marbot and bucketAV, two products that we sell on the AWS marketplace. And this is episode number 76, and we are recording this on April 26 in 2023. In case you're watching this live on YouTube or LinkedIn, feel free to ask your questions in the chat. Otherwise, just write a comment or send us an email and we will pick up your question in the next show. So all the details to reach out to us are in the description below the video as well. So Andreas, what are we going to talk about today?
yeah, so Michael, first of all, we have a big announcement. So we talked about a new product that we are both building in the past few episodes, I think. So finally, we have released that product. I think it was 2 weeks ago already, Michael. So the product is bucketAV powered by Sophos. So this is what we have been working on. It's finally out, and the first customers have already subscribed to it. We're getting feedback from them already. So we are really happy with that. And in this episode, we will talk about basically what we have learned while building this new product. And maybe Michael, do you want to kick off this with a short history about bucketAV?
Yeah. Yes, I will. And Andreas, before I start, just let me quickly introduce what bucketAV actually is, right? So for maybe not everyone is aware of. So what it is described in a couple of words it's an antivirus or anti-malware solution for Amazon S3. So when you upload a new file to S3, it scans it. You can also scan the files at regular intervals, like a full scan, and a couple of other options how you can scan your files. So that's what it is, antivirus for S3. That's it. And we started this little project with exactly this kind of feature set in 2015 as an open source project. And I can actually not really remember, but I think we built that for a client actually. And then we put it out in the open. And in 2019, we realized that we could turn this into a product that we can sell to clients that are interested in like support and all the other commercial features. So we added bucketAV powered by cloudonaut, so that's the other engine that we support, to the AWS Marketplace in 2019. And now this year, 2023, we released bucketAV powered by Sophos. So basically we replaced the cloudonaut engine with the Sophos engine, which is a commercial engine compared to cloudonaut, which is an open source engine. And this actually sounds easy, right? And we thought that more or less in the same way. So okay, we just switch out the engine, and that's kind of it. So We will talk about the pitfalls in the next kind of minutes or half an hour. So we actually discovered a couple of things that are of interest. One last thing around the history is that today we serve more than 1,000 customers that are actively using bucketAV in their AWS accounts. So we support the product, we maintain the product, we also create new features for the product. So this is one of our 2 core products that we sell on the AWS marketplace. So Andreas, let's get started. What are the challenges that we kind of discovered while working on this new product?
Yeah, Michael. So basically, we thought about so bucketAV powered by clamAV was around for quite some time, as you described, and some of our customers asked us about other anti-malware engines. So, for example, Sophos or other providers, and we postponed this, and we had that in the backlog for a while. Then we thought, okay, let's do it now. So we got a contract to resell Sophos, and then I thought, okay, implementing that shouldn't be too hard, right? Because basically all we do is we replace clamAV, and instead of telling clamAV to scan an object, we tell Sophos to scan the object, and everything around that, basically what we do, downloading the files, setting up the AWS infrastructure, all of that could more or less stay the same. Now, clamAV and Sophos are a little different, and we run into some issues there. So I think one of the biggest difference, so besides that, those are 2 different ways to scan for malware. So Sophos is a professional provider for that, and clamAV is an open source version. I think the other big difference from a technical point of view, besides the scan engine itself, is that Sophos scans files without a file size limitation, while clamAV always had that limitation of 4.2 gigabyte. So you cannot scan files that are larger than that with clamAV, but with Sophos you don't have any limit. So basically we can now, in theory, scan files with 5 terabyte, because that's the maximum file size in S3. So that's, I would say, the biggest differences between those 2. And the things we run into, most of them come from that difference. And the first thing we had to implement is that anti-malware solutions need a database, basically with the information about all the malware out there. So they have their own database formats, and you basically need to synchronize that, because you need to make sure that every EC2 instance that runs bucketAV has the latest malware database available to scan the objects. And so we had to implement that, and we have had a solution for that before. So basically our idea was to use S3 buckets to distribute the data, and to have 1 bucket in each region that we sell bucketAV in, so that our clients then can just download that directly from S3 within the same region. The big benefit of that is that as long as the traffic stays within the same region, you're not paying for the traffic when it comes to fetching data from S3. All you pay is the GET requests. So it's relatively cheaper than, for example, having a CloudFront distribution somewhere and distribute it globally. If you do that, you have to pay for the traffic or other options. So having 3 buckets in each region and then replicate the data into all of these buckets is, in our scenario, the cheapest option to get that up and running. Of course, you then have the problem with you need to synchronize the data to all those buckets. So in our case, we need to fetch the data and then make sure we copy it to all the S3 buckets in every region. And Michael, I think this is something that you implemented some time ago, but basically what we're using is an EC2 instance that downloads the data and then uploads it to S3. And I think the kind of clever solution is that we're using Systems Manager to run that job periodically on the machine. So this allows us to have monitoring in place in case those jobs fail. We get notified via Marbot about that, and I think that's a very clever solution. You might ask, why not using S3 replication instead of having an EC2 that copies the data to 20, I don't know how many buckets in all those regions? The answer is that when you use S3 replication, you do not have control over the order in which the data gets replicated. But that is important in our scenario. And the other downside of S3 replication, at least if you want to have guaranteed and short replication lags, is that you pay quite a premium for that feature as well. So that are basically the two reasons why we are running that on our own EC2 machine. Yeah, so that's that learning, Michael. I think that's a valid scenario to make data available worldwide.
And there's maybe one thing to add, Andreas, because I just like today I got a budget alert for this AWS account that hosts the Sophos mirror, and it is actually, I mean, this is not necessarily surprising, but we pay quite some money for cross-region traffic now, because we from our Ireland, this is our main region, we copy the data to all the buckets in all the other regions, so we pay for the cross-region traffic between the regions. And this adds up in our case, so we are paying money to AWS for doing that. So that is something that you have to keep in mind when you implement something like this, that you are charged for this traffic, right? I mean, that's the reason why we put a bucket in each region, because we don't want to be charged for that later on when our customers download the files. But for us to push them into the buckets, we have to pay the fee, which is okay. But it's just one thing that I want to mention.
Yeah.
Okay. So this was one challenge, Andreas, and I was running into another challenge. As you already mentioned, we can now download files up to 5 terabytes in size. So this is the S3 limit, and it's actually quite funny side note here. So what is actually the limit, right? I mean, AWS is not quite certain about that. So in the documentation, they sometimes tell us it's 5 terabytes. So sometimes they tell us it's 5 tera, how is it called? I don't know how, TIPs or TIBs. And this is quite a difference in bytes. So they are not 100% certain about that. Turns out that they use a very interesting definition of a gigabyte, which is not what they use in all the other products. So in all the other products, if you, for example, pay for storage, for EBS volumes, or for also memory on EC2 instances, it is they are using this notation where they use this 1024 bytes is 1 megabyte, or MIB, and 1 megabyte actually, and then this goes on and so on and so on. But for S3, they use a different definition because they mixed things up a little bit there. So they on their documentation or in the FAQ they say it's a gigabyte, but it's actually not a gigabyte. It's a GIP, and this is a little bit confusing, but it is just a side note. I opened a support ticket, and they of course promised to improve the situation, but let's see if that happens. So the thing that I actually want to talk about, sorry for that, is that when you try to download a 5 terabyte file from S3, things get a little bit tricky, because our first implementation that we had in place was kind of implemented on the assumption that the maximum file size that we can scan is around 4 gigabytes. So we didn't have a lot of optimization in place there. But now with 5 terabytes, it matters, because if you download using the AWS Node.js SDK, it is actually, you will never finish a 5 terabyte file. It will take days to download it, because the way the SDK is implemented is that it only downloads basically one part at a time. What you can do with S3 is you can have multi-part uploads. So this speeds up the way you upload large files, and you can use the same mechanism for downloading. So you can have multi-part downloads. So basically what you say is you can tell S3 to either give me part number X of this large file, or you can tell S3 give me this byte range of the file. And then you have multiple HTTP requests in parallel to kind of try to maximize the network utilization. Because if you download just a single part from S3, it will be not utilizing your 10 gigabits or even 50 gigabits network connection from the EC2 instance. So it's much slower than that. So what I was looking for is a library to implement that, so multi-part downloading. And it turns out in Node.js it's not really available. So there's nothing from AWS in the SDK, it's just not supported, they just support the multi-part upload. If you look into other SDKs, for example the Java one, you will see this implemented. So they have that, you have the transfer manager in the Java SDK. So this is kind of lacking in the Node SDK. I also looked for like third-party libraries. Turns out there's one from AWS Labs that is 6 or 7 years old. I mean, we cannot use something that is not maintained since 7 years. There's some other projects on NPM that are also kind of the same problem. They are not maintained anymore. So we started our own project, Andreas, S3 Get Object Accelerator, it's called. And it does a couple of things, and I learned this actually the hard way. So let me quickly summarize what it does. First, it downloads in parallel. Okay, that's kind of the easy thing. Second, it has a custom DNS resolution because you are limited to, I think 2.5 or 5 gigabits. I'm not quite sure if it's 2.5 or 5. I think it's 5 gigabits per network flow on EC2. So if you connect to only one IP address, and then this will be the same flow, then you can only download with 5 gigabits, no matter how many parts you're downloading at the same time, if it's always the same IP address. So if you resolve the DNS name just once, then you will run into this limit. So I kind of resolve all the IP addresses, and then I kind of round robin through them and things like that. So that's the first thing that the library does. The second thing is it kind of gets rid of the AWS SDK. Turns out AWS SDK for Node.js is very slow. So if you really want to download a large file and not you shouldn't use it. It really has a lot of overhead. So we removed that as well. And with those two optimizations, we were then able to utilize the EC2 instance much better. It of course depends on the EC2 instance that you are using. So they have different network limits. They also have different CPU limits. So what we learned is that the instance types with high CPU performance compared to memory, for example, provide us the best performance. Especially, I think it was called, Andreas, help me out if that's not right, M5ZN instance, right? So this is a Intel processor with 4 point something gigahertz. So this is the fastest chip you can get on AWS.
Exactly. Mm-hmm.
Yeah, so that provides the best performance for us. I'm still not able to fetch with, for example, 50 gigabits. Node.js doesn't seem to support that. So, but it turns out that there are actually other limits as well. For example, the EBS volume gets a limit as well because we are not using Instant Store at the moment. But yeah, that's the story. Let me quickly send the link to the project in the chat. Or have you already done that?
I've already done that.
You have already done that. Okay, right. Thank you for that. So yeah. That's it. So if you ever want to download a large file from S3 in Node.js, then check out the project. So we are using it in the product, and it is like a core piece of why this is now significantly faster than the SDK. Yeah.
So Michael, I think the really crazy thing that I didn't expect that how difficult it really is to get the best performance out of an EC2 machine and S3. So I think one other thing that I remember that you ran into was that now you had all those, you fetched a S3 object in multiple parts, you had multiple things running in parallel, and then I think you run into this other issue that the EBS volume, the GP3 volume, by default is limited to a certain amount of throughput, and you reach that limit. So you had to increase the provisioned IOPS for the GP3 volume. So I think there's so many things that you need to oversee when you really go into high performance stuff on EC2 and S3. That's really crazy. So I didn't expect that to be so complicated, to be honest.
I think we talked about this a couple of times, right? So like performance testing on AWS is not easy. So there are so many limiting factors. You have to kind of have them all in your mental model before you start the test, because you have to observe them all. Yeah. If you're not aware of one of those limits, so this will be the one you will run into and you have no idea why. So that's really tricky. And of course, you have to measure those things and display them. And I mean, there is most of this data in S3. There is not all of the data in S3, so some of this was only available in the I cannot remember all the details, but there's this network driver. I don't remember. Is it how's it called? Enhanced networking or something?
Mm-hmm.
And this publishes, I mean, you can use the CloudWatch agent to publish some of its metrics to CloudWatch, but it's not by default there. So you will see some of the networking limits, or if you hit some of the limits there. But I mean, this is really, it's not easy to get. So you have to invest quite some time to get all these insights into the network stack. So yeah, this took me, I would say it's actually not 1 week, it was 2 or 3 weeks.
Yeah, it's crazy. Okay, Michael, so let's move on with another topic. So the next topic is basically about the AWS Marketplace. So we sell all our product through the AWS Marketplace. And the beauty of that is that our customers, they subscribe to our product through the marketplace. And then our software fee, our service fee shows up on their monthly AWS bill. And for us as a small business, this allows us doing businesses with companies and clients all over the world, in many, many different countries with ease, because AWS collects all those payments for us and then invoices the customers and then just basically sends us the money. So that's really a really easy thing for us. On the other side, the AWS Marketplace, from a technical perspective, is a quite complicated beast, I would say. So there are a lot of different product options those days. So it started with you sell just AMIs in the marketplace. So I think that was the beginning of the marketplace. So you sold your AMIs through the marketplace, and customers were paying an hourly fee for every hour that the EC2 instances running your AMI were up and running. But nowadays there are much more options available and makes everything more complex. So with bucketAV powered by clamAV, we are using that exact model. So we sell the AMI and our customers pay an hourly fee for the software. So that's it. But with bucketAV powered by Sophos, we wanted to do a different pricing model. And our intention was to not just bill for the EC2 instance, but to bill for the processed data, for the scanned data per gigabyte. So that was the idea. I think because we think consumption-based pricing models are fair for both sides. So if you use it a lot, you pay more. If you use it very little, you pay very little. And it also frees us from bundling a running EC2 instance together with our with the product and what we can charge for it. So that's really a good thing, I think. So we implemented that. At the first, we wanted also to combine that, so a fee per gigabyte that we're scanning with a monthly fee per AWS account and subscription for our product. So this was our initial idea. Unfortunately, that's not possible, at least not that easy. So we switched to just charging for each processed gigabyte. That's what we currently have. And how do you implement that? So how does that work? So when you just sell your AMI and you just charge for the AMI, you don't have to implement anything. Everything is handled by the marketplace. If you want to do metered billing, like we do now, so in our case, charge per processed gigabyte, you need, of course, to send those data to the AWS Marketplace API, because the marketplace needs to know how much data has been processed. And that's what we have implemented, basically. So now bucketAV basically collects how much data was scanned, and every hour, each instance sends to the Amazon Marketplace API the metered amount, so how many gigabytes have been processed. And you can send that from every running instance, and then the marketplace, AWS Marketplace, is summing that up for all the instances every hour. So that's how that works. The challenge then is, so how do you make sure that in case the EC2 instance is not capable to send those metered billings data to the marketplace API, how then you need to make sure that your product sometime stops, because otherwise customers could just, I don't know, filter the traffic to the marketplace API or stuff like that, and they will never pay for your product. So you need to implement that. You need to implement that it's only working if the metering is working, but you don't want to stop everything with the first error from the API, because you don't want customers be affected because of a AWS API issue. So yeah, there's a lot of complexity with that, but in the end we figured it out, and now it's up and running. And I think what I really like about this pricing model, Michael, is that we are now only charging for what the customer really gets benefit out, that is the processed data. So I really like that approach from that perspective.
Yeah, that's right. So talking about the cost of the solution, what we also had in place already was a way to run bucketAV on spot instances. So this was actually the default, or is still the default, because it's based on EC2 instances, and this is a very good use case for spot instances, because when a scan job fails in the middle, because EC2 interrupts the EC2 instance because the spot capacity is not available anymore, we just pick up the job on another worker and we continue with the scan. So it is a perfect fit for the spot model. What was a problem up to a couple of weeks ago, before we released that, was that in the last month, or actually year, I would say, the spot capacity, I think, was reduced by AWS on purpose, because they kind of try to probably optimize their bottom line a little bit, to force people to use on-demand instances if they don't want to be terminated every couple of minutes or hours. So what we see quite often is that spot capacity is not available, and not just interrupted, and not just not available in where some EC2 instance types, but really not available over larger availability zones and instance types combinations. So what we had, what our customers were experiencing is that all of a sudden no capacity was available anymore, because all the spot capacity was terminated and there was no fallbacks available. Because usually we just pick one from a different a set or from a different type and things like that. So what we ended up with is we now have a fallback to on-demand. So if AWS interrupts all the spot capacity, we will spin up on-demand instances for our customers. And I think the biggest kind of, or the biggest surprise is that AWS does not support that out of the box. And there are a couple of reasons probably for them why they don't want to do this, but for customers this is really, I think it's not very, I would say, I mean, it's a lot of pain basically to implement this on your own. So what I figured out is a way to have two auto-scaling groups, one that runs the spot instances and one that runs the on-demand capacity. And the on-demand capacity basically is always updated to the difference between what is desired spot and what is running spot. So if desired spot equals running spot, the on-demand capacity should be 0. But if we desire 10 spot instances, but we only have 5 running, then we will spin up 5 on-demands. And we can implement this basically with a little bit of CloudWatch alarms and some like magic tricks with metric math. And then we can kind of push that information into the fallback, on-demand fallback autoscaling group. And I've written a blog post about that. So if you're interested in the details, you can check that out. I think it's a very slick or lean solution. Let me copy the link into the chat here quickly. Oh, Andreas, you already did that. All right.
I did.
Yeah, so this is for everyone that uses spot instances, I think a good solution. It's low effort, it's not error prone, there's no Lambda functions or things like that involved. It's just native AWS features wired together in a way that makes it work. So yeah, check that out if you are running spot instances. So there's one last thing, Andreas, that we learned. So let's walk through that as well.
Yeah, so I think this is another thing. So as now bucketAV powered by Sophos is able to scan larger files, so up to 5 terabytes, as we discussed already. So it's possible that, such a job runs a few hours. If you need to download 5 terabytes, even if you optimize everything, this takes a while, right? Okay, so what we then found out is, now we have the problem that when an EC2 instance gets terminated, we need to make sure that everything shut down gracefully. So this is the case in case the autoscaling group decides to downscale, or basically decide capacity that gets decreased, and the autoscaling group then starts terminating an instance. Then we need to make sure that bucketAV running on the machine has some time to finish the job, do the metering and reporting, and then terminate the instance. And the other thing is, in case of a spot interruption, so if you run a spot instance and this gets interrupted by AWS, we also want to make sure to terminate the machine gracefully. So if possible, finish the running job, again, do the metering and reporting and everything. And so we thought about implementing that. And we did so basically by using two techniques. So one is both the auto-scaling state of an EC2 instance and the spot interruption state of an instance is available through the instance metadata service. So you can get the information about what is the intended state that the auto-scaling group has for this instance. So this could be either in service or terminated. So by calling that endpoint, you know that the auto-scaling group decided to terminate an instance. And then there is the other metadata service resource that you can access, which says, is this instance marked for spot interruption? And then you have basically 2 minutes to finish your work. So that is the other thing that we do. So what we now do with bucketAV, we pull those two metadata resources to get information about the auto-scaling group status and the spot status of the instance. And whenever we notice that the instance gets terminated, we then start a graceful shutdown, try to finish the running jobs, do not accept new jobs, do the metering and so on. So that is what we implemented. The other part of the solution that we had to implement is a so-called auto-scaling lifecycle hook. So this has been around for years. Basically, you can insert an auto-scaling lifecycle hook for terminating or launching instances. In our case, we do that when an instance gets terminated. And this means the auto-scaling group first sets the instance to this will be terminated. Then you have time and you need to complete the auto-scaling lifecycle hook. And only if you do that, then the auto-scaling group continues with really terminating the instance. So basically, you can do your work there. So that is what we have in place. And each machine, each instance is responsible for doing that individually. So the code for all of that runs on each machine. So we're pulling the instance metadata service for the auto-scaling instance state. And based on that, we start a shutdown. And then at the end of the shutdown, we then signal to the auto-scaling lifecycle hook. This has been completed. So basically continue and terminate the instance. So this is how you implement that. There's one more thing here to consider. The auto-scaling lifecycle hook has a heartbeat timeout. So the instance for job, if it takes some time to shut down the instance, you need to send a heartbeat. You can configure that. So in our case, I think we do that every, I think 6 minutes or something. We send a heartbeat from the instance that tells the auto-scaling group, this instance is still shutting down, so do not terminate it from the outside. Wait until we finish our work. And we do that up to 12 hours because that's the maximum time a job can run because of some SQS limitation we have. So that's the implementation. And by the way, we will shortly after recording this, we will publish a blog post where I have some code snippets if you're interested in how to implement this in your own for your own EC2 instances.
Yeah, Andreas, let me add one thing, like just that the listeners get an idea how long it actually takes.
Mm-hmm.
If you run on an M5 large instance and you try to download a 5 terabyte file, it turns out this will, I think it takes around 13 hours
Mm-hmm.
based on the network throughput of that instance.
Mm-hmm.
And because you have a 10 gigabits burst bucket credit, but if that runs out, you will be slowed down to 1.74 gigabits per second. And if you download with that throughput, it will take just 13 hours until the file is downloaded. So that was one of the problems with the 12-hour timeout that we see also in SQS. So you cannot, like when you get a message from SQS, you can always extend the visibility timeout, but it doesn't work longer than 12 hours. So for example, at the current state, M5 large is not able to scan a 5 terabyte file. You need to go to an extra large, and then it works. But it then takes it takes like maybe, I don't know, 8 hours or something. So you really need the big machines if you wanna scan 5 terabytes. Because it's actually not so easy to move that onto your machine. Yeah, it takes some time.
Yeah. So I don't know if anyone has ever stored 5 terabyte on S3. So it should be quite hard to upload that as well in one single file. Yeah. But yeah, so if that's the case, bucketAV is ready for that. So if you have the need for scanning data stored in the 3 buckets for viruses and malware, check out bucketAV. We hope you enjoyed our story about what we've learned from building and releasing that product. If you have any other questions, feel free to send them in the chat or send them later. We will answer them in the next episode as well if you want to. So Michael, I think that's it, right?
Yes, that's it.
Perfect.
So thank you very much for listening.
Yeah.
And we see us next week, right?
Yeah, and that's a big announcement for next week as well. So next week we will have the launch party for our book, AWS in Action, the 3rd edition. So on May the 2nd at 12 p.m. European Central Summertime, we will have a launch party on YouTube and LinkedIn Live, and then later in the podcast as well. So we will there share our story about writing the book, AWS in Action, give you a little overview. We will have the printed book in our hands to show you live on live on camera. And we're also going to raffle a few copies. So if you want to have the chance to win a free copy signed from us, both of us, make sure you're not missing the launch party event. In general, to not miss any of our upcoming stuff, make sure you subscribe to our newsletter or our podcast or our YouTube channel. That would be great.
Right. So that's it, Andreas. Thanks for having the time to talk to me today. And then we will be back next week.
Yeah.
Bye.
Bye. Thanks for listening. Bye.